Okay, jumping from polar to Cartesian equations, I have a handful of examples here, and I think it's because, this one isn't as straightforward as going Cartesian to polar, where we really just needed to substitute what x and y were equivalent to and solve for r. This one has various tricks associated with it. Alright, so r equals 3 sine theta. Remember, our goal now is to get equations in x and y, and hopefully we recognize the equation, but sometimes there might be a little bit more work involved. So, sine theta, r equals 3 sine theta. Alright, I guess the only thing I see to begin with is the fact that sine theta is y over r, right? So let's make that I don't know why I did that. Let's make that substitution, y over r, and we still have r equals 3 times y over r. Okay, now one trick in many of these is to try to get an r squared, because once I see an r squared, I know that is equivalent to x squared plus y squared. So there are various ways about doing these, but rather than getting r and doing the square root, it's more common to attempt to get r squared. So what we have now is we do have r squared, because I'll multiply r on both sides, right? So I'd have r squared equals 3y, and now I can make that substitution, x squared plus y squared equals 3y. Okay. I'm going to end there for a second, but we are going to come back to this problem. I have everything, right? R and thetas are gone. I have x's and y's. Awesome. But I don't really know what that is yet. I'm guessing a circle, but this other y, right? We might not be used to that. Like, what do we do? So anyways, I'm going to come back to that here in just a second. R equals 2 secant theta. So I have nothing over here about secant. You could, I guess, say it's a reciprocal of cosine and put r over x. That would work. I'm going to show a different approach. So I know secant is reciprocal of cosine, so therefore I'd have r equals 2 over cosine theta. And if I multiplied cosine to the other side, right, I would have r cosine theta equals 2. And r cosine theta, we know, is x. So sometimes, rather than making a bunch of substitutions, if you can directly get r cosine theta or r sine theta, then you know those are x and y, so try to manipulate it, if possible, to that. Now, most often, we always want sines and cosines, right? They're the easier ones, and if you notice this one, actually, r equals 2 secant theta, as a Cartesian equation, is just x equals 2, and why are you doing that? And that's just a vertical line at 2, right? Where r equals 3 sine theta in the first one, a bit more complex. I'm going to have to do some work to see what that one is. Again, I'm going to come back to that in just 1 second. One more I want to do here. Okay, r equals 4. Again, we could do square root and then see what r is. Remember, you have plus or minus, but here's what is more common. Okay, whatever we do to one side of the equation, we can do the other. So if I just square both sides, to begin with, if I have r equals 4 and I square both sides, r squared equals 16 is equivalent to saying r equals 4. Now, r squared is x squared plus y squared. And therefore, this I recognize as a circle, right, centered at 0, 0. and the radius is 4, since it's x squared plus y squared equals r squared. Okay, very rough looking circle, but there you go. And last, if we did need to solve for y, kind of talked about this in the other video, but we'd have to get two separate functions, right? We'd have this upper half of the circle, and then we'd have a lower half of the circle, basically the positive and the negative square root. So you can see r equals 4 is a much simpler equation, right, to work with. All right, let's go ahead and jump back to this first one. So this is not in standard form. X squared plus y squared equals 3y. I don't really want a point plot. We can't plug that directly in a calculator. If I am in polar mode, right, I could just put this polar equation in and see this graph. But we're so accustomed to x's and y's, it's important to see the value of this new system we're looking at, this new way of graphing. All right. What we would need to do, one, we could solve for y and then get two separate equations. Okay, that is possible. But in standard form, just like x squared plus y squared equals 16 is a circle that is in standard form, this should be a circle, so let's get it that way. We first need to subtract 3y. Right, x squared plus y squared. So I'm going to end here because, that answer is okay, but I don't really know what that graph looks like at all. All right, subtract 3y equals 0. So now with these y's, I have to complete the square. All right, and in order to complete the square, I kind of do it in a two-step. I go half of -3 is -3 over 2, and why that's important is because that is going to be, I could just say y minus 3 over 2. Let me erase that. Y minus 3 over 2. Okay, that's going to be the perfect square for the y. The x, I didn't need to do anything. It's done. And then we square -3 over 2, and that's the term we have to add to both sides. So that's 9 over 4 plus 9 over 4. Okay. If you complete the square differently, that's fine. Do it the way that you were used to it. But now, right, this wasn't terrible. I'm just saying they could get more complex. So now it looks like we do in fact have a circle. The center, it remembers hk, so it's x minus 0. The center's at 0 for x. And for y, it's a minus 3 over 2, so it's positive 3 over 2. That's my center. And then we square root this to see the radius. So the radius is 3/2. So we have a center, if this is 1 and this is 2, is here, 1.5. And the radius is 1.5, so I need to go up a little bit more. Okay, and so it should hit down here, over 1.5, back 1.5, up 1.5. Again, not perfect, rough sketch. All right, so it is in fact a circle. All right, either form works, oops. If you left your result as this, that's not incorrect. I don't really know what it is. This is better, it's in standard form. Okay, or technically when we solve equations to write in functions, we would need to solve for y, and then we'd have a positive and a negative square root, so we'd have two separate equations. Okay, when in polar coordinates, all it was is r equals 3 sine theta. It looks so simple, right? Okay, moving forward. Theta equals 3 pi over 4. This is a weird one, and suppose you could solve this again in various ways. You could also kind of picture it and see what the equation would be, but most commonly we use tangent, okay, because tangent would give us, we're trying to get rid of thetas and r's, right? There is an r in there, so I don't really want to try to do anything with cosine or sine because I'd get r's. So what we do is we take tangent of both sides. So tan theta equals tan 3 pi over 4, right? Tangent of 3 pi over 4 is negative 1, and then we make this substitution, tan theta is y over x. So y over x equals negative 1, and right, we solve for y because we're in a Cartesian equation, so multiply by x, so y equals negative x. And that is a line with slope of negative 1, y-intercept 0, and it's this line here, which, as I said, we could have graphed it and kind of pictured what the equation would be, but there's theta of 3 pi over 4, right, and r could be anything, so it creates this line. Alrighty, last one. R equals 1 over 4 cosine theta minus 3 sine theta. Looking at this, like, well, if I squared both sides, I'd have r squared, right? But then I gotta square this fraction over here. It's kind of ugly, so I don't really know. Let's start with actually just making this substitution. Cosine theta is x over r, sine theta is y over r. Let's do that first. Okay, x over r, y over r. So we have r equals 1 over 4 times x over r minus 3 times y over r. Okay. I guess we could get an LCD. I mean, we have the LCD as r and change it 4x minus 3y. Yeah, let's do that. It doesn't matter. I see a few ways we could go about this, but 1 over 4x minus 3y over r. Okay. So initially what I was thinking is like, let's just multiply by r over r. That would have worked too. Now that we have this, we have division. So 1 over 4x minus 3y divided by r, which becomes multiplied by r over 1, right? I'll write that out. R equals 1 over 4x minus 3y divided by r. But division means multiply by the reciprocal. So this is saying instead of divide r times 1 over r, right? Actually, let me take that back. I'm reading this wrong. This is saying 1 divided by, right? The initial was 1 divided by that stuff. 1 divided by 4x minus 3y. This way I just clear the fraction at the start, and I should have done so. That's all right. Which means multiply by r over 4x minus 3y, because it's just 1, right? 1 multiplied by that. Okay. Now what? Well, I guess I'm going to multiply by 4x minus 3y on both sides to cancel that out, right? Cross product, I guess. And then at the same time we could divide by r, but I'll leave it for now. So we have 4x minus 3y times r equals r. So when we divide this r, it's not 0, right? We get 1. 4x minus 3y equals 1. Now we've got rid of all the r's and thetas. It's a line. Probably, best to solve for y, putting y equals mx plus b form, slope-intercept form. So 3y equals 4x minus 1. So y equals 4/3 x minus 1/3 once I divide by 3. And now I know what the line looks like. Slope of 4/3 with a y-intercept of -1/3.